Hi, welcome back to 345 Delta Foxtrot. My name is David Forgerson. This is my fifth video on how to build a Vans aircraft fuel tank. Part one was getting started, part two was everything you need, part three was more stuff that you need, more than everything. Part four was building the tanks, and part five is going to be about final thoughts and Dev 3. And Dev 3 is my third video in the Dev series, which is about deviations from the plans. So I'm going to try and talk about any deviations that I made from the plans in building the fuel tanks. This is the list of topics. Basically, it's here so that you can jump to any particular topic that you're interested in. All the slides are numbered, so feel free to fast forward to any particular topic. Okay, topic number one is dimpling and countersinking. And on page 4 of the instructions for the RV10, it basically tells you to countersink the holes in the skin where the baffles are going to attach. And my opinion is that this is a bad idea. You're your own builder. You're an adult, you make your own decisions. However, I very seriously recommend that you at least think about this step carefully. And don't just jump right in and do whatever they say. The basic problem is that the skins are too thin to countersink, in my opinion. The skins are about 32 thousandths thick, and I don't think you should be countersinking anything that's less than 40 thousandths thick. And you might want to go back and watch my video 345 Delta Foxtrot RV10 Dev 2. It's about Service Bulletin 43, which is a service bulletin for the elevators. I'm not going to go back over all my reasoning for thinking that countersinking of thin metal is a problem. Just go back and watch that video if you have any questions about it. In this particular case, there are already hundreds of holes in the skins that have been dimpled. So you already know that the skins can be easily dimpled because you've already done it hundreds of times. And also, if dimpling is a problem, you're already screwed. You've already dimpled, hundreds of things in the skins, so doing a few more isn't really going to matter one way or the other. And if you do decide to countersink, I highly recommend that you be extremely careful not to over countersink any of the dimple holes. I think it'll just lead to problems down the road. Okay, one quick thing is the baffles are not symmetric. One side is different from the other side. And the way you tell the sides apart is in the row of holes on the baffle or on the skins where the baffle is going to go. On one side, there are 3 closely spaced holes in a row, and on the other side, there's not. And it's pretty easy to overlook. And when you're clecoing everything together, it doesn't really matter. You might not notice. But when it comes to doing the fuel tank sealant and riveting everything together, it matters a lot. So you want to be very careful at that point to make sure that you've got the baffles on correctly. And as you can see, I marked mine with yellow or with blue painter's tape, and I recommend that you do something like that to just ensure that you don't make a mistake at the last minute, and it would be a real mess if you did. Okay, another thing that I found that I haven't talked about in my previous videos was a pretty good way to scuff everything. Before you, well, wherever you're going to apply fuel tank sealant, the CS3204, you want to scuff it beforehand. And you know, that definitely applies to the baffles and the flanges of the ribs where the baffles are going to attach, and the flanges of the baffles, the skins where the baffle is going to attach, etc. So a fairly easy way to do it is using these, this is from AliExpress, and they called them Mini Drill Abrasive Brush Nylon Buffing Polishing Wheels. They're pretty inexpensive. You can get 10 of them for $3, so it's 30 cents a piece. And I use the red ones, which are 320 grit. And those may be not quite coarse enough. So you might want to try the green ones. They're 180 grit. I'd get some of each and then just use them on a piece of scrap and decide which one you like best. And then after you scuff, you're going to want to clean everything with acetone. And another new toy that I have is this cordless rotary tool. This is not the one that's shown here is not the one that I have, but it's very similar to it. I think basically I bought the cheapest one that Amazon had that was 8 volts. And so far I like it pretty well. And I have a corded one as well. And I almost always opt for the cordless one. It's a lot more convenient, but certainly not necessary. Okay, topic number 4 is CS3204 A2 versus B2. And I've already talked about this in my previous videos, so I'm just gonna barely mention it here, and you can go back and watch my previous videos if you have any questions. This is the data sheet for CS3204, and I highly recommend that you read the data sheet. And it says CS3204 Class A is a self-leveling liquid. That means that it basically has the consistency of honey. And the Class B stuff is a paste that will not flow or sag on a vertical surface. So it has the consistency of peanut butter. And I used both, and I think that that's the correct way to go. I basically recommend that you at least give it a try. going to have basically a quart of B2 and probably a little bit more. So since you're going to have to buy a little bit more B2 anyway, instead of buying B2, I would recommend that you buy A2. And whenever you have a horizontal surface, that you use the A2. Now that means that you may have to do one side, and that'll be horizontal on the bottom. Let that dry overnight, and then flip it over and do the other side. So it's a little bit more time consuming, but I think you get a lot better result. And in my previous videos, I showed photos both ways with A2 and B2. And I personally think that the A2 just looks and seals up everything much better. So give it a try. Okay, to apply the 3204 A2, I almost always used a 20 milliliter syringe with a, I don't know how you pronounce that. I pronounce it Lauerlock, but I doubt if that's correct. But anyway, one of these Luer-Lock 20 milliliter syringes. And then you buy some of these blunt tip dispensing needles for Lauerlock syringes. And you get 100 of them for $8, so they're 8 cents a piece. They're pretty inexpensive. And I found that the dispensing needle, the steel dispensing needle, is a little bit too small. It doesn't come out quite fast enough. So I just took a pair of pliers and pulled the steel part out and just used the plastic part, and that works pretty well. And if you want it to come out a little bit faster, you can run a drill, a number 40 drill through it and open it up just a little bit more. And that's what I did, and that's what I recommend. Okay, topic 6 is a quickie. In my previous video, I recommended that you set your workbench height for working on the fuel tanks to about 2 feet, so that the cradles that you built are, the bottom of the cradle is about 24 inches off the ground. For doing the baffles, I dropped that down to about 1 foot, about 12 inches off the ground. And I think that's about right. It's not critical. It's just whatever you find convenient. And that's what I found the most convenient. And another thing you might want to consider is when you go to apply the sealant to the flanges of the baffles, it's nice if they're, how do I say this? They're sitting vertically, but not with the long way sitting vertically. They're about 5 feet by 10 inches. Okay, you want the 10-inch part sitting vertically. You don't want them sitting 5 feet in the air. And so I just built a little wooden thing so that I could clamp them to it. And it was easy to apply the sealant to the flanges of the baffles. It's not a big deal, however you want to do it. And then when you go to apply the sealant to the what's it called? The web of the baffles, then I just set it on some 2x4s, and that works fine. Okay, So should you use a gasket on the fuel level sensors or not? They come with a gasket. However, in the RV14 plans, the Vans clearly says discard the gasket supplied with the fuel level sender. So that's what I did. I think that the gasket would make them make replacing one of the fuel level senders easier, but I'm not sure how well it seals. And of course, Vans does not say anything about their reasoning here. But I'm kind of assuming that maybe a few people have reported leaks in the gaskets. And so they're currently recommending that you throw the gasket away and you just use the fuel tank sealant. And they recommend that you have a 32nd inch or slightly larger gap between the base plate of the fuel tank fuel level sensor and the inboard rib that you're attaching them to. So I used some thin stainless steel washers that I had I think I actually measured them, but I don't remember how thick they were. But I think they were in the ballpark of a 32nd of an inch. It's a little bit messy getting all those washers in place when you've got fuel tank sealant, but it worked out okay. You can do it however you want to do it. But I did want to point out that this in particular, because it's not in the RV10 plans, it's only in the RV14 plans. But the RV14 is a more modern design than the RV10. So I'm assuming that Vans is just lazy and not updating the RV10 plans. Okay, I added an additional fuel level sender to each tank. And originally I was going to attach it to the outboard rib, just like the regular one is basically attached to the inboard rib. But the problem is, if you do that, it's going to be right underneath the fuel cap. And I don't think that's a very good place. I don't know exactly how long the nozzle is on the when you add fuel, but I don't want anybody sticking anything in the tank with the fuel sensor right underneath it. So instead, I mounted them as shown in the picture here. They're not on the outboard rib. They're not mounted to the next rib. They're mounted to the one after that, so that the float is actually near the second rib. You want the float as far outboard as possible. And I think it worked, came out basically okay. You can see that the float is a little bit twisted, and that's when it's empty, but the outboard sensor, you want it to be accurate when the tank is full. When it's empty, it doesn't matter so much because you've got the other sensor for when it's empty, the inboard sensor. It fits nice against the top when the tank is full. And I just riveted, I used pulled rivets to hold the sender in place. You know, it can't leak, or, I mean, you don't have to worry about any leaks or anything like that. So pulled rivets seem plenty strong, and they're permanent. You know, I didn't want to use any threaded connection or anything in case it came loose or something. So then the existing wires are actually already soldered to the sender. Is just a potentiometer, a variable resistor, and it comes with wires already soldered to it, and then you know, so anyway, what I did was I just cut those wires and soldered my wires in place. Now, I know you're not supposed to solder stuff on an aircraft. However, the wires that were already there were already soldered. So, you know, must be okay, at least in this particular case. And my experience has been that soldering gives very good connections. And then I just ran the wires through nylon bushings to the inboard side, and I put fuel tank sealant around the bushings to hold the wires kind of in place. And then have a connector on the inboard side. Okay, one thing I don't like about the fuel tank senders that Vans uses, and I have no idea how common they are. For example, does a Cessna use the same type of sender or sensor? I have no idea. Could be that everybody uses them and that they're extremely common, but one thing, well, there's actually a couple of things that I don't like about them. One is they seem pretty wimpy. They do not seem really structurally sound to me. And another thing that I don't like is that all the electrical connections are exposed. So the potentiometer itself is exposed, and all the connections to it are exposed to the fuel or the fuel vapor, depending on if the tank is full or close to empty. And the concern is that any sort of spark would be catastrophic. Your plane is just going to blow up. It's going to explode. And the voltages are low and the currents are low, so the chance of a spark is fairly low, but you should be very careful about the wiring. If a higher voltage, if a wire were to wear through, the insulation was to wear through and it were to touch a higher voltage wire or something like that, it could be very bad. So that's one thing I like about the CIES fuel level senders, is they're magnetically coupled, and so there's no exposed electrical connections. At least that's my understanding, just based on looking at their pictures. So anyway, you've been warned. Okay, so what I did was I added my own wires, and So I have 2 wires for each sensor that come out on the connector on the inboard rib. So 4 wires total per tank. And that gives you lots of options for how you can wire everything up. For example, you can just use the 2 wires on the inboard sensor and wire it up just like a regular Vans follow the instructions tank. And if the inboard sensor were to crap out for some reason, you could just disconnect it and use the outboard sensor. And what I tentatively plan to do is to connect the 2 sensors in series. And so the outboard sensor will be accurate when the tank is full, and the inboard sensor will be accurate when the tank is empty. And so you'll always get an accurate reading. And you could do a similar thing by connecting them in parallel, but it seems to me like connecting them in series would be better. Now, it does depend a little bit on how good your avionics is. What you'd like to do is connect them in series and then calibrate the tank. So measure the resistance when the tank is empty, measure it when it's full, add 5 gallons to the tank, measure it, add another 5 gallons to the tank, measure it, and tell your avionics the resistance for each level and let it interpolate. But I don't know how smart the avionics is actually going to be. Okay, so basically the final thing that you do is you install the baffles, and that's where you seal everything up, and after that there's no turning back. It would be a real pain to have to open up the tanks to fix some sort of problem at that point. So you want to be very careful when it comes to installing the baffles. So do a final check with the fuel level sensors with an O-meter, make sure they're working correctly. Make sure that everything is scuffed and cleaned. Clean it with acetone. Clean the inside of the tanks in general. Get rid of any excess fuel tank sealant. Get rid of any dust or dirt or anything. Blow out the tanks. Wipe them out with isopropyl or acetone. Then you might want to add some blue painter's tape when just basically to reduce the mess when you go to insert the baffles in the tanks. And do a very thorough final inspection. Make sure that you don't have anything that could possibly be a leak or turn into a leak. Make sure that your vent line is in place and everything looks good. All that kind of stuff. And then when it comes to installing the baffles, you have basically a 2-hour working time on the CS3204. So I found that I was working alone, and I found that I could get everything, the sealant mixed up and coated and everything in place and Clecoed together in 2 hours. However, I could not get everything riveted. That probably took another 2 hours to get everything riveted. maybe even longer by the time you get the very last few rivets done. And I tried to make sure that absolutely everything was ready to go. And I highly recommend that you think about it in detail and make a checklist. And here's just a few items that you might want to put on your checklist. Like make sure your workbench and your cradles are all set up and ready to go, that you have paper covering everything to minimize any sealant getting on the floor or on your workbench, and make sure your scale and your beakers are all set up and ready to go. Your syringes, if you're going to use syringes, are all set up and ready to go, etc. Just do everything you can in advance so that when you finally start, everything goes as quickly and as smoothly as possible. Okay, that's it for this video. That's enough. 5 videos on how to build fuel tanks. If you like these videos, please subscribe, give them a thumbs up, leave a comment. It helps the YouTube algorithm recommend these videos to other people, which is not a big deal. But it also gives me some encouragement to make these videos. I don't have all that many subscribers and or that many viewers, so I'm not highly motivated to make these videos. But if you subscribe and give my videos a thumbs up, that will definitely give me some motivation to make more videos. And they are a pretty fair amount of work. So, I appreciate any comments or thumbs up that you give them. So that's it. Thanks for watching.